Okay, let us discuss another numerical problem from engineering mechanics by Professor Timoshenko, Young, Sukumar, Pati, and Rao. Problem set 2.3, solution to 2.36. How to use Lami's theorem, and it is all about concurrent forces, means forces passing through the same point and lying in the same plane. Just look at the diagram. A force P is applied. Here a force P is applied to the right hand side at point C as shown in figure O. Determine the value of the angle alpha, value of this angle alpha, for which the larger of the string tension is as small as possible and the corresponding values of tension in the string 1 and 2. And we have to find the tensions in the string 1 and 2. Now, this is a string 1, this is string 2. You are pulling with a force P to this side. Now, since 1 and 2 both are strings, so there will be a tension force, axial force, that is a tension force. For the string 1, this is the joint. For the string 2, this is the joint. So let S1 is the tension force in string 1. So it will be pointing away from the joint, S1. If you look at this point, it is to this side. If you look at this point, it is to this side, the same as 1. Similarly, for the string 2, if you look at the point C, S2 is to this side. And if you look at this point, it is to this side, same as 2. Now, so both will act away from the joint C, S1 and S2. I have drawn the free body diagram at point C. Point C for you. Now the question is how this angle is alpha and this angle is 60. Here, if you draw a line parallel to the support AB, let me draw it for you with a scale. If you draw a line parallel here, if you draw a line parallel, then this line is parallel to this line. This is the transversal, so this angle will be alpha. That is what I have shown here in the free body diagram. This line is parallel to this, and this is the transversal. This is 60, so this will also be 60 degree. This will also be 60 degree, which I have redrawn it for you here. So at point C, there are three concurrent forces. Tension S1, tension S2, and the force, applied force P. This is angle alpha, this is 60. So they are concurrent at point C. They are lying in the same plane, let's say plane of the paper. So let us apply Lami's theorem at point C. So what it will be, P over sine of this angle. P over sine of this angle. This straight line at the point C makes angle 180 degree. So P over sine of 180 minus within bracket 60 plus alpha, this is the bracket, is equal to S1 over angle between S2 and P, that is this angle, that is equal to 90 plus 60. Then similarly S2 over sine of this angle, that is equal to 90 plus alpha. S2 over sine 90 plus alpha. So if you look at here, these two expressions are same. If you cross multiply these two, you get S1 as 90 plus 60, 150. This comes to this side. So P sine 150 over sine 180 minus 60 minus alpha, that is 120 minus alpha. If you cross multiply this and this, you get S2. You get S2 as S2 as S2 is equal to P times sine 90 plus alpha. Let me from here S1 in terms of P, if you cross multiply these two, you get S1 as S2 sine 90 plus 60, that is sine 150 over sine 90 plus alpha. From these two you get this, from these two by cross multiplying you get the same S1, right? Now let me go to the next phase. Since the larger of the string tension is as small as possible, then the conclusion is S1 must be equal to S2. So S1 must be equal to S2. Therefore, S1 over sine 90 plus 60 is equal to S2 over sine 90 plus alpha. So these two cancels. So we are left with sine 90 plus 60 is equal to sine 90 plus alpha. Now sine 90 plus 60 is equal to sine 150 sine 90 plus alpha, taking the inverse of function. Therefore 150 is equal to 90 plus alpha. So alpha is equal to 60 degree. Now don't look at this. So therefore S1 is equal to S2 is equal to, now since I have found out alpha, so S1 is equal to S2 is equal to, using here P times sine 90 plus 60 over, from here this comes to this side, P times sine 90 plus 60, P times sine 90 plus 60 over sine 180 minus, within bracket, 60 plus alpha, so I put the value of alpha as 60. So 60 plus 60 is 120. Oh no, put it this way, sine of 180 minus theta is same thing as sine theta. Sine of 180, think of this as theta, so is equal to sine theta, that is sine 60 plus alpha, this is 150. So P is sine 150 over sine 60 plus 60, I have put the value of alpha. So this becomes P sine 150 over sine 120. With a scientific calculator, put sine 150 and sine 120. This comes out to be 0.5773 times P, the applied force.